It is given that a is a positive constant. A1. Sketch on a single diagram the graphs of y equals the modulus of 2x minus 3a and y equals the modulus of 2x plus 4a. When you draw the graph of a modulus, you just draw the graph as it usually is without the modulus, but for the parts where it is negative or where it goes below the x-axis, you just need to flip it so that it's always positive. So if we look at the two graphs we have to draw, for y equals 2x minus 3a, the gradient of the line is 2 and the y-intercept is at minus 3a. For y equals 2x plus 4a, the gradient is also equal to 2, but the y-intercept is at 4a. Since the two lines have the same gradient, we are looking at drawing two parallel lines. If we draw the line without the modulus first, one of them has to pass through 4a on the y-axis, and the other one has to pass through minus 3a on the y-axis, and both lines need to be parallel. And when it becomes a modulus, you just reflect the part where the graph is negative in the x-axis so that it's always positive. And we will do this for the other one as well. So reflect the negative part of the graph in the x-axis so that all of it is positive. And when you reflect the graph of y equals 2x minus 3a, the negative part of it in the x-axis, it should cross the y-axis at 3a. 2. State the coordinates of each of the points where each graph meets an axis. So it wants us to state where the graph meets the x-axis and where the graph meets the y-axis for both equations. For the graph of y equals the modulus of 2x plus 4a, it meets the axis here and here. For the y-intercept, we can already tell from the equation that it meets the y-axis at 4a. For the x-intercept, however, we need to work that out, and the x-intercept is when the y equals 0. So all we need to do is substitute y equals 0 into the equation and solve for x to get the x-intercept. And we get the x-intercept equals to minus 2a. Therefore, the coordinates where that graph crosses the axis is at 0, 4a, and minus 2a, 0. For the other graph, y equals the modulus of 2x minus 3a, we already know that the y-intercept is 3a from the graph. And again, for the x-intercept, we need to work that out by substituting y equals 0 into the equation and then solving for x. And once we do that, we get x equals 3a over 2. Therefore, the two coordinates where the line crosses the axis is at 0, 3a, and at 3a over 2, 0. B. Solve the inequality modulus of 2x minus 3a is less than the modulus of 2x plus 4a. We already drew the graph of the modulus of 2x minus 3a and the modulus of 2x plus 4a in the previous part of the question. So technically, we could use the graph to solve this inequality as well, but we're going to solve it using algebra and then check our answer with the graph. So whenever you're trying to solve equations involving moduluses, the modulus can never be negative. So whenever we solve equations involving modulus, we can square both sides because when you square something, it will always be positive. So we can solve this inequality using algebra by squaring both sides and then simplifying it and then solving for x. So we want to simplify and rearrange so that x is on its own on one side of the inequality. Okay, now we got minus x is less than a over 4. So we can multiply both sides by minus 1. But when we do that, don't forget to flip the sign of the inequality. So we have x is greater than minus a over 4. Now we can check this with the graph to see whether it makes sense. So remember that a is a positive constant. So we're looking for x is bigger than a negative number. So if we look back at the graph that we drew, we are looking for the inequality where the modulus of 2x minus 3a is less than the modulus of 2x plus 4a. So we're looking for the path or the area where the graph of y equals the modulus of 2x plus 4a is bigger than the other graph, and that is over here. So that corresponds to a point on the negative x-axis onwards, right? So at that point and above, and this makes sense because we were looking for a negative number that corresponds to minus a over 4, and it looks like it makes sense. So therefore, our answer should be correct.